last speaker today is Eric Brewer. Eric is a professor of EECS here and the VP of Infrastructure at Google. He has his PhD from MIT, but he does have a bachelor from Berkeley. Eric founded Ink2Me and later sold it to Yahoo. He founded the Federal Search Foundation and helped build the first Gov, and now I guess USA Gov. He is a member of the National Academy of Engineers, an ACM Fellow, a holder of an Infosys Foundation Award and the Mark Weiser Award. Thanks.
Thank you so much. This will be, comparatively to the rest of the day, a less technical talk, broader audience. We'll see if that's a good or bad thing. You can tell me at the end. I will have plenty of time for questions, and so we can definitely discuss this, go as technical as you would like. So the good news is, I almost feel like we're kind of done here. You have a supercomputer, probably have two of them. The cloud is a supercomputer. And so in terms of the computing power you need, it's all there. Just to put a few things in perspective, roughly what I think of as a supercomputer, first one I had any experience with was a Cray 2. That's roughly an iPhone 4, and it's also an Apple Watch. So if you have an Apple Watch on, or an Android watch, that is a Cray 2. CM5, which was the computer that helped get me my professorship at Berkeley in the 90s, that's kind of about half of a Samsung S6 phone, and it's about one Haswell core. So Haswell is kind of a modern Intel computer, so one core, that's about a whole CM5. You can take a whole 2000 era supercomputer, IBM's ASCII, that's roughly a PlayStation 4. And it's roughly a 32-core Haswell. And that's an interesting one because that's something you can get for $1 an hour. So that's kind of amazing. Good job, Dave. So you literally can carry multiple supercomputers with you, and you can rent another one for $1 an hour whenever you need it. And of course, all the apps you use have a supercomputer for each of them. There's certainly arguably a supercomputer behind search, driving directions, Uber, Amazon, eBay, Facebook, and many, many, many others. The number of supercomputers you interact with in your normal day, I would say, is in the tens now, not counting the ones that you're carrying with you. So where does that put us? It puts us kind of where we have the thing we think of as the current cloud, and to first order, it's infinite computing. What it looks like is a sea of virtual machines, which is a little bit strange to me for a couple reasons, but that's what it is today. When you rent that 32-core Haswell, what you're getting is a virtual machine with 32 cores and a bunch of RAM and maybe some SSD. But if you were to go back a little bit and looked at it, how we looked at it on the Now project that led to Ink2Me, and by the way, Dave and David Culler and Tom Anderson were very kind and helpful to me when I was new faculty. That's also part of the Dave model and Dave legacy. But the 90s version of cloud actually didn't have virtual machines at all. That's because Mendel was still at Berkeley, I think, and hadn't gotten to Stanford yet to go reinvent virtual machines in the Disco project. Maybe I don't know how he would say it. He's here. Rekindle, revive, bring them back. That's why the project was called Disco Back, by the way, bringing things back from the 70s. But no virtual machines, and the focus was on scalable services and kind of you just took kind of a sea of storage as kind of your basis, and you would scale services up and down on these clusters of commodity nodes. If I look where cloud's going, it's actually back there in an interesting way. That the cloud we're building now is, again, a sea of services, a bit cleaner, but basically what we want people to program is not a virtual machine, because machines are annoying, but to actually live in a sea of services written by themselves and others, which give them great leverage. And so in some sense, VMs ended up being this transition technology to allow enterprises to get what they had into the cloud. It's great for that. But I think even Mendel would say, in fact, he did say in his paper, it's not where we're going. Right? It was a mechanism to make certain things more usable, and it did that fantastically well. But I kind of feel like in 20 years, we'll look back and say, oh, VMs were great tool that got us over this hump of how do we get to a programmable infrastructure. So the way I think about this is actually that I want you to think of the cloud as apps are built as a collection of services. Each service is its own independent thing. That's important because it means different services can be built by different teams with their own deployment schedule. That's how you get high velocity in modern software engineering. So the independent upgrade and versioned APIs is an important part of that. It's a given that each service is durable and highly available. When you're programming using these services, you don't worry about them losing data or going down generally. That's not quite true. But in some ways, you can think of this as like object-oriented programming or actor programming. I see Carl Hewitt's here, where the objects are persistent and they don't forget stuff. So it's a really handy kind of object to have as your basic platform. It's also the unit of access control. It's the unit of sharing. And because of that, it's also going to be the unit of provisioning consumption of services by third parties. So when you write applications that do things with maps, you're probably using the Google Maps API. That is an example of a third-party service, or you can use the search API to have search as a third-party service and used in your application. So that model of different players meeting at the API level is really what we want for how we program the future infrastructure. And if you heard about Docker or containers or Kubernetes, these are all technologies that are about moving us in this direction to have this kind of more abstract, higher level programming view of the cloud versus the traditional machine view. All that being said, I kind of feel like that's the technical future of the cloud. Right? We can stop there. We have infinite computing, we have infinite storage, and that's not actually the parts I worry about. I kind of feel like I can see how to get all that done. It's going to happen. It's not trivial, but it's already in progress. What I don't think is understood, and it's come up many times today, which is a good sign, is what does it mean to have infinite computing and infinite storage? And I would say we're not really ready for it. So Randy mentioned various kinds of surveillance. This is the picture of the traffic cameras in France. They're literally everywhere. There's tens of thousands. Yep. France in particular likes traffic cameras. This is a picture of a LiDAR 3D reconstruction from an airplane or a helicopter. These typically generate something like 400 million points, and they can be at 5 to 10 centimeter accuracy. So it means that you can fly over an area and know the complete 3D model of that area in one pass, and then convert that into something that's got reasonable shape. And what I bring this up because both of these are examples of just crazy pervasive data collection. Right? And this is part of the cloud too, because we've made infinite storage and infinite computing available to everybody, and this is one of the consequences of that, is that we collect everything and we process everything. And so I'll give you a few other examples. I leave out the Internet of Things because I knew Randy was going to talk about it. 400 million hours of video, that's uploaded every day for YouTube. That's 400 hours per minute. So in 1 minute, people around the world uploading videos upload 400 hours worth of video, right? So that's about a petabyte per day, right? Just a crazy, crazy number. We have to store all that, by the way, which is why disks are not going anywhere. It's still better for lots and lots of YouTube than Flash is, at least for 10 years. But in addition to all the kind of data collection that we already have talked about, there's two other kinds that I think are interesting. One is everyone's carrying around a super sensor in addition to a supercomputer. And in fact, that's where all the YouTube videos come from, is basically mobile phones. But they're collecting other things too, whether you know it or not, such as Wi-Fi and Bluetooth signals, GPS logging. There's a lot of other things that you get with having your super sensor. And of course, people generate their own content that they often regret. And this is going to come up quite a bit more because I kind of feel like most of this data is collected for some purpose that we'll assume is noble. Not all of it, but assume most of it's connected for noble. This is a case where people are choosing, with presumably consent, what they want to share, and sometimes they make bad choices. So what I want to go with this is to point out that we can't really make informed consent when we provide data. We think we have informed consent, but we don't. And I'll talk about what I mean. So there's a common practice right now where your insurance company will offer you a discount if you're willing to put a speed monitoring device on your car. This makes sense because if you don't speed, you're less likely to be in an accident, less likely to cost them money. They should give you a lower insurance rate. So you will get a discount if you're willing to share just your speed, not your location. The problem with this, you can probably guess, is that if you have a speed log and machine learning and a map, then I could know your location. So when you gave consent to have the insurance company know that the speed of your car, you were not presumably consenting to let them have your location. But it was the same decision, right? It wasn't the same decision at the time you made it. It became the same decision when machine learning got better, right? So this project is from Rutgers. It's called Elastic Pathing. But basically, given your home address and a log of your speed, you can just figure out, oh, well, 65 miles an hour for this stretch, you had to be on a freeway. There aren't that many freeways that fit this pattern. Then you slowed down to 10 for this long and 20 this long. There's only one possible path you could have taken, right? The most likely path, in some sense, is revealable. As one of the researchers put it, the data once collected does not go away, and improvements make it possible to plumb more private information. Right? This is really the essence of it. So what I want to get to here is that I want people to realize that the revealed data changes over time. Right? You cannot consent when you give up data to all the things you're actually giving up, because you don't know what you're giving up. Right? And so I would question, what does consent even mean in a change in the amount of processing we have applied to data retroactively? So then you say, well, what are we going to do about this? The first question is, can you delete at all? That's not easy. That's actually a big discussion in Europe at the moment, but it's generally not well understood, I would say. For example, you can delete something from a search engine, but that doesn't delete it from all the other hosts that have it. Is it really deleted? No, it's just slightly harder to find. And by the way, there's many other search engines and many other ways to find stuff. Maybe we should delete stuff by default. That's actually the email policy of many corporations, that after 18 months, emails that you didn't mark specifically will be deleted. They do that because they found that those emails often are used in future litigation, and it's better to not have them around. By the way, on Google, you can delete all the stuff that Google knows about you. If you go to your My Account settings, you can manage your privacy settings. So you have the ability to delete stuff, but you still have to take action to decide what you want to delete. So in general, we don't have a good story on deletion, either by default or even once you realize you would like to change your past decision. Related to this is the question of, do we even want privacy? I certainly speak for myself, feel like I want privacy. The reason I ask the question is that many people behave as if they don't want privacy. Right? When you post stuff to known public sites that affect your future job options, that is you not valuing privacy or not understanding it. Right? Right? But your behavior implies you don't value privacy. Right? You trade your location information for various things. You trade your shopping list for a small discount. Maybe that matters, maybe it doesn't, but in general, we behave in ways that imply we don't care that much about privacy. But I think the bigger one is that you have to evaluate privacy not in what you've consented to today, but what a powerful entity with unlimited storage computing power could do to it in the future. Right? And we don't know what that is, but it's a lot. Now, so that's one vector that I worry about, and I think it's important to talk about because I think it's still early enough we can address these kinds of things. Related to this is, once you have more ability to do processing on data, you tend to want to use it for filtering. And the way I think about this is filtering is trying to find badness so that you can then make more informed decisions. And there's lots of different ways to do this, but the one that came up recently in multiple contexts is, should you factor in an arrest in a hiring decision? Right? Berkeley recently decided not to factor arrests into hiring decisions. The pro is it's probably true that previous arrests correlate with bad performance. I don't actually know, by the way. I have no idea. People seem to think that, and therefore, historically, will reject candidates that have an arrest on their record. The con is we don't actually know if they were guilty. Right? Arrest does not mean guilt. Arrest, we have this thing called innocent until proven guilty. Arrest is not in that. Right? You can be arrested and be found innocent. But we do know that arrests correlate with poverty and race. So if you're making decisions that say, I'm going to filter on being arrested, you are also choosing to filter on race and poverty. Right? And that's a kind of a general problem here. It gets a little worse, which is that for a variety of reasons, people that are poor are more likely to be surveilled than people that are not. So if your metric is things that you find mark people as less eligible, you'll find more bad things about poor people, categorically. Right? For example, if you participate in food stamp programs, you give up some surveillance rights, maybe even including fingerprinting and drug testing. Right? There are other programs that you participate in, you give up some privacy for tracking to agencies. Right? And those might be reasonable decisions, but the point is now there's more information about poor populations in general than there are about wealthy populations that don't need any assistance and don't make this trade. And finally, this gets to some of the points that were made earlier. If you're using a data-driven process in the cloud, is it any better that the cloud does this filtering for you and says, oh, I categorically rejected all the people with arrest records and all the people that correlate with this? They're actually building into your system essentially a bias against various things that you might not choose. Right? And again, the cloud's not biased, it's the way you're using it that's biased. That's a very hard problem to fix. Right? And Google is definitely guilty of this. This is our most famous thing. This is not acceptable behavior, to be clear. This was Google Photos captioning images and deciding that this black woman looked like a gorilla. Why did this happen? Well, most likely bad training data. If you didn't have enough African American pictures in the training set, you might not train correctly. So again, the programmers weren't biased, the system wasn't biased, but the combination of the data and the system led to a biased outcome. And I call this unconscious bias because of, and by the way, Google takes this part super seriously and views this as an unacceptable behavior. But the point is, it's kind of what you get if you don't understand all these issues and you're just doing correlation. Right? It's the kind of the natural thing. But it turns out humans are the same. So there's a lovely space called unconscious bias. This is something that is training I took for Google and that I would encourage everyone to take. And what it really comes down to is that the hippocampus is part of your brain that makes decisions quickly. There's other parts near it, things like the flight response. Those are all parts of your brain that make decisions quickly for survival. They are absolutely biased decisions based on past correlations. And sometimes they're just like the Google Photos bias. In humans, we have this thing called the prefrontal cortex, which is your higher brain, and says, I'm about to make a bad decision that I know is biased. I won't actually make that decision. I will override it and do the right thing. And then when you take an unconscious bias test, what they're doing is they're giving you questions, but they don't give you enough time to answer, except by using your hippocampus. And so we see the first answer, we see your instinctive answer, which is biased. And people that are unbiased or claim to be unbiased are very upset by their own behavior when they take this test, myself included, right? So when you say you're unbiased, what you actually mean is you've trained your prefrontal cortex to make up for whatever biases you have in your lizard brain. Right? That's the best you can do, right? And this training is awesome. I highly recommend it for everybody. The cloud has no prefrontal cortex. That's the root problem. It's the same that Sarah just mentioned. The closest I could find was the laws of robotics, which are basically rules that robots are supposed to follow in science fiction to make up for whatever bad behavior they might have in the past. But that's not actually adequate. There is no short answer here. I think the only way this goes forward is in line with what Sarah was arguing, that programmers actually have to build the line of reasoning above these things to actually get good decisions. And that means we have to be conscious of the bias and conscious of the things we want to get done as we apply these techniques. And it's not easy. In particular, obviously, they have a few problems. The programmers are themselves biased, hopefully not as biased as the examples I'm showing, but it'll have kind of different bias sets. Training sets are absolutely biased, which is what led to the Google Photos problem. Putting simple rules on top is complex but error-prone because it's going to miss a lot of cases, right? So what you really want to teach is everything is the prefrontal cortex, which is a broad, value-based reasoning system with deep entity knowledge. And I think that's a good goal, but I don't think it's easy. And also, we have a related problem, which is, especially in some of the modern machine learning systems, we don't actually know why a decision was made, right? It's not, it was the, it's the most likely outcome, and I believe that it is, but the reasoning behind why it would be a good choice is often hard to parse out, and there's people working on that. But this is something that has to be fixed at the moment at least, at the services level, when you're trying to leverage infinite computing and storage to do the right thing. And it's not at all easy, but I think it's something we should aspire to. To shift to less dystopian and more utopian, the cloud is actually super empowering, and I think people don't appreciate how much so. So I do a lot of work in developing countries, and one of the things we learned there is that as you bring mobile phones to an area, GDP goes up, and that's now been measured by economists. It's a pretty significant effect. In fact, the GDP increases from mobile phones are far more in aggregate than all the foreign direct investment ever given to any country, right? So it's the most effective way to improve the economy of a country is to give it mobile phones. And after that, it turns out now it's slightly better to give it broadband. And digging into it, so there's a lot of study of the mobile phone effect. There's less study of the broadband effect. But I would say the broadband effect is because phones are personal productivity, like taxi drivers, for example, or fishermen bringing fish to the right market. Those are two things that have been studied. Broadband ends up being corporate productivity through email and things like that. That groups of people end up being more productive. That part is not proven, that's speculation on my part. But it's actually a bigger effect than the mobile effect. I actually think the cloud is a significantly bigger effect than broadband on GDP and access because I see the way people use it. And the way to think about this is what you can learn as a schoolgirl in Mozambique is totally different if you have access to the cloud than if you don't, right? Even your own self-education from things like Wikipedia. I know one girl learned how to play piano over Skype. Right, there were no piano teachers in her area. Right, the ones I've worked on tended to be telemedicine, but it's the same thing. It's really because there's no specialists. You connect people in rural areas to specialists and specialized systems. That is hugely impactful on their lives. And finally, even just seeing that people can do something themselves via the cloud, self-education, is in fact, it's self-inspiring and gives people hope. And actually, the hope is the most important part of the cloud in developing countries, right? It gives people the thought that there is a way out or a better life or some chance. So these are huge factors, and I don't think, it's not just the connectivity, it's actually the services. The one most used at the moment is actually Facebook, and the main effect it has, and WhatsApp, both of those, to be fair. And the main effect they have in the short term is simple things like basic productivity and communications, but it also has led to remittances, meaning the arrival of money and coordination of money from overseas, and many other kinds of services. So just trying to wrap up, and I'll take as questions as we can. I kind of feel like we solved the problem of infinite computing. There's more to go, more computing will be better, but I don't feel like there's no bottleneck there. We know how to do it. I think the issue is we're not ready for it, right? So it's going to be a little messy. And I mentioned a few risks. What can we extract out of existing data that we didn't realize? what kind of consent was involved, and how do you get, are you supposed to get new consent when you can do new things with the data? That's not the current policy. Right? The consent is forward with whatever you can do with it. It's not even clear if everything should be public. And by the way, not everything is public. There are countries, typical, like even in the US, certain things are not allowed to be recorded by Google on Street View. Things like military bases. So even though they're in the public, they are not viewed as public information. So there is at least some things that are not public in public. But maybe we should think about what that boundary is, because you are going to be super surveilled from all directions, including your neighbors and the sky. Is all that public all the time? I don't know. By default, it is. Finally, we don't have great ways to manage the data once it's in the system. I don't really believe the best policy is going to be data is in storage forever and can be mined forever. I don't think that's going to lead to the future we want. I don't know how to fix it, but I do think this is the room where it's got to be fixed. All right, I will stop there and take any kind of questions you have.
So I like that a lot. I think I have a comment to make about machine learning, ethics, bad behavior by autonomous systems, and what it has to do with the cloud, which hasn't yet become what I hope it becomes, which is a composable set of services, so that I could have a service that teaches ethics and correct behavior to another. We compose learning systems and teaching systems in the cloud to suppress data that are too old about me, for example. I mean, you know, there's all sorts of opportunities here to build systems that we don't think about building today because we don't have all the expertise. But just as someone can learn how to play the piano via Skype, we can have a machine learning system that learns how to be reasonable via something else.
We have infinite computing power. It's up to us what to do with it.
Well, we have to make it composable, which means, you know, yeah.
One point I forgot to mention, because I took out the slide it was on, is that one thing the cloud's made different is now everybody has infinite computing power. It's not just your government, right? It's your neighbor, it's your friend, it's your companies, your enemies, right? It's a little more complicated because of that.
Eric, fascinating talk. About your comment with respect to bias and the prefrontal cortex, when machines are not involved, do we have a solution for this problem? Because I'm pretty sure if you take a naked picture and show it to people here, half will think it's art, half will think it's offensive, and some will giggle like teenagers. So do we have a handle on this problem at any level?
I think it's a hard question to answer, but I would say the societal answer is what it means to be an adult, roughly, is that you use your prefrontal cortex to not make bad decisions. And you're not perfect at it, and if you're bad enough at it, you get punished. Teenagers, by the way, don't have developed prefrontal cortexes, right? That's a literally, you don't get that till you're about 25. So the cloud is like a teenager in some ways. Hopefully, the cloud will be able to express a wide range of views. Because it's going to have to, actually, because every country has its own standards of what's acceptable.
Eric, two quick stories and then comment as you will. So the first story happened to me yesterday morning. Costco called me up and said, we see from your bill that you just bought some contaminated vegetables that have been recalled. Please return them for a refund. And I hadn't eaten any, so that was very much to my benefit. The second was that a famous economist got pulled off of a flight. The flight was delayed for 2 hours because his seatmate got nervous because he was intensely doing mathematics while they taxied out and called him off. They showed it's a differential equation, found out he was a famous economist, and okay, that's fine. But if they just Googled it from the name, which they had, they'd have found it out. So in both those cases, giving up privacy would have been beneficial to the individual involved. Just comment on that, take it where you will.
I kind of feel like that's why we have to decide seriously, do we want privacy, right? Roughly the argument in Brave New World was that you would choose pleasure over privacy, right? And I think at some level we have, but at the same time, I think we don't have to make such a black and white line. We can be very precise over time with what we want to be private or not. And even actually the Google privacy settings page, it's like many, many options of what you want to delete and how you want to manage your private data, because it is complicated. It doesn't have to be simple.
So this is a question that combines sort of cloud privacy and do you trust the programmers? So let's go back 40 years. I suspect a few people here have read the 1975 book Shockwave Rider by John Brunner. Okay, which of course had a cloud and it knew everything, and people worried because they didn't know who knew what about them, right? And it had a hero who had a replicating worm that would go rewrite his identity everywhere, a useful thing, right? Well, I read the book, laughed a bit, and in 2 weeks saw the worm that Ken Thompson did that he talked about in his Turing lecture. Okay, and we were the only ones at Bell Labs who found it, actually. But it was sort of like I had laughed about the book and then saw it within 2 weeks. And what Ken was doing, of course, was checking the extent to which you as a programmer could trust the software you got from somewhere else. So now, I saw this thing about the programmers that better put some ethics in. Well, do we trust all the programmers? In this environment, who do you trust? What kind of mechanisms do we have that prevent data from filtering out and getting stuffed away somewhere? So maybe address that.
I can say what we do for Google, and it's hard to know what's adequate or not. In fact, the standards will change over time, but in practice, the thing that works the best is actually code review, because it's required actually for any changes that go into production. And so it has to be colluding programmers before you get some of the serious problems. And of course, the other big thing is access control, meaning that there's very few people, for example, that have root at Google, and we try to make that list smaller every year. And most people can't actually see user data. You actually have to, there's under separate access control. So you could still write bad programs, and you might get them through. We have to depend on essentially retroactive mechanisms like auditing and firing to catch those, and that is basically the plan of record. And I would say that's been okay, but that's kind of tuned after 10 years. And if you're talking about how many small companies do you trust that might be a single programmer, right? Most apps are single programmer. Do you trust all of them? You go by the reviews or the stars, right? That's not actually a validation mechanism, right? So, but it's the best we have.
So I had
Can't see where the mic is.
Can you see me? Right?
Thank you.
I had another complication to throw in there. You probably know that I'm working on this project with Randy and David to track people's travel patterns so we can do better urban planning. And so I've been worrying about this for a while. I actually taught this undergraduate class, and I made the students read 2 chapters of The Circle, which is this book about, proto-Google and so on. But I do want to sort of highlight that while it is useful to people to keep their data, it's also really, really powerful to aggregate the data, not just to make money, but also for other social good things. There are existing examples of this, right? Flu, spread, and so on and so forth. So it's almost like you want to have the ability to own your own data, but to share it when
I do think
needed,
controlled sharing is where we have to go.
or something like that.
Yeah. We can't do controlled sharing very well yet today, but I do think that is a very important direction. With provenance.
The census model, that you can't be able to derive an individual result, but you can get the demographics?
Yeah, he's mentioning the census has a goal that there's enough aggregation that you can't pull out individual samples, but that hasn't stood the test of machine learning yet. And I don't think it will. If I can give you a good Google example, it turns out there's only one translator living in Algeria that speaks Italian. So now we know who it is, but we never intended to know who it was. But because there's only one of them, it's obvious who it is.
Eric, the advent of search engines and the level at which the community believes them to be authoritative is very important. There seems to be some experimental evidence which indicates that people's voting is biased by the order in which the information they get about individual candidates and individual issues is presented by a search engine. How do we guarantee that the search engine does a fair presentation of information?
I can't say I know how to do that. I do think it's the right goal. We have a related problem, which Sarah mentioned too, which is when you start contextualizing information, I'm more likely to show you things you already believe, right? Because you're more likely to click on things you already believe. And so I'm reinforcing polarization unintentionally with those kinds of policies. And I think that is also a bad thing. That we call diversity of results, and we do try to provide a diversity of results, but that doesn't mean they're ordered in a fair, consistent way by definition because you're personalizing the ordering.
I think the discussion of privacy so far has focused mostly on people's private concerns. What worries me much more is the ability of a society to be a proper democracy if everything is known. But when leaders can see when incipient movements form, it's great if you know when a plague is gathering so you can stop it. What about an opposition movement?
I do think minority views are one of the things that are hard to keep when you basically more and more have this kind of first step of filtering that's done automatically. So again, not saying we can't solve it, but I know we won't solve it if we don't look at it.
Two more questions.
So Eric, regarding the privacy that you mentioned and the cloud and the space, so I just posed that question about, for example, underlying of the Bitcoin, which is a blockchain, which is actually serves some type of privacy while it does actually semi-anonymous in some sense. So do you see any trend on that direction? Because if you look at the same thing, we can do the transaction, the bank is not private, but we can do the same thing in the Bitcoin, which is somehow private and somehow is actually anonymous. Can you do that one in the cloud space of the future?
I do think there will be ways to do various decisions more anonymously, including even things that are not obvious like reputation. I think the challenge with Bitcoin is it's because it's essentially centralized in its decision making. If ever something leaks out, then it's known everywhere by everyone. And so it's kind of an all or nothing anonymity, which I think is unlikely to stand the test of time for everybody. You can definitely reach consensus without a centralized entity, and there's cases where that's useful. My gut is that'll end up being used in a relatively small set of areas because centralization is so much easier for many, many other reasons, and also better as a business model. But that doesn't mean we shouldn't pursue that as one of the important options on the table.
Dave Unger here near the door. If you could look a little further ahead, what comes after the cloud? Because when I got here, we had the cloud. It was Ernie Kovacs, and now it's something else. What's the next huge thing that's not cloud, that supplants cloud?
I don't have a good answer to that. He suggested wired bodies. I do think just expanding the penetration, including into bodies, is not, to me, going to supplant the cloud as much, extend it. So in some ways, I would argue maybe there isn't something after because this just grows into what that becomes. This is an essential thing.
Okay. So you don't think we won't move back to doing all the computing, with machines we have ourselves and communicating? We'll still effectively timeshare other machines and go
there's lots of reasons you'll end up using the cloud, but I think the core reason it won't be as distributed as you're implying is that group state is actually super valuable, right? I think even old services, cloud services like Evite, are essentially enabled by the cloud because of their group state, not because of the cloud per se. and certainly communication apps too. But I think there's all kinds of things that fit the group state model that are fundamental to having it in the cloud versus where you happen to be right now.
Thanks. Hope to have a beer with you sometime.
Happy to.
Thank our speaker.